Host.
Are there any other nominations? Councillor Van Hulst, will you let the nomination stand?
I shall, Madam Chair.
And if there are no other nominations, I don't even believe we need to vote. I believe he's acclaimed. Congratulations, Councillor.
And to you, Madam.
We need a first. Oh, it's been moved by Mr. Khan because I believe since he nominated, and it's seconded by Councillor Park. We do need to vote. So we will vote on so we'll vote by show of hands. All in favor? Any opposed? The motion carries. So now we'll go to disclosures of pecuniary interest. I see none. So I'll start by saying the City of London is committed to making every effort to provide alternate formats and communication supports for council, standing or advisory committee meetings, and information upon request. To make a request for any city service, please contact accessibility@london.ca or 519-661-2489, extension 2425. And we will move to scheduled items. Item 3.1, is it 4:30? Yes. So we have a staff presentation there. Welcome.
Through the chair, thank you very much for this opportunity to speak before the working group here. At council direction, we went to seek out some autonomous vehicle and ride-sharing experts to bring towards to council today to talk both to the Bus Rapid Transit Group, and in addition, we also took this opportunity to have our experts in front of city staff this afternoon in a related project similar to a previous council direction related to developing a connected and autonomous vehicle strategy for the City of London. As part of this process here, I just wanted to give a bit of a brief slide, or some brief slide presentations here, just to give you a bit of a background definitions. This would be similar to what was presented in the memo that accompanied this working group. And then I'd like to just turn it over to our experts. They'll give some brief 10-minute remarks or so. Following that, we've prepared some frequently asked questions based on some of the autonomous vehicle questions and ride-sharing questions that are out there in the industry. And we'll give the experts an opportunity to respond to that, at which time I'll turn that back over to you, Madam Chair, to conduct any additional questions that the working group members would like to do. So with that, I'll move into my brief presentation here. Just a little bit of a background information for certain definitions, just to make sure we're all on the same page. So autonomous vehicles, I think we generally get a sense of what this type of technology implies. Really just vehicles that are have the ability to sense the surrounding environment and react to it, to be able to successfully navigate transportation systems through AI sensors, GPS, other types of technologies. And I think one of the big promises that a lot of people are hoping with this technology is to be a major improvement to road safety. I guess that would tie into some of the Vision Zero type of initiatives the City of London already takes into account. It should also be noted that all automation or all automated vehicles are not created equal. The Society of Automotive Engineers has created some formal classifications from level 0 to 5. Level 0 might be your Model Ts to level 5, which would be no pedals, no wheel, nothing. It would just be something that would be able to drive you around on command. And it should just be noted too that through the pilot program with the province of Ontario, as of January 1st this year, OEM or original equipment manufacturers are now allowing level 3s to operate on Ontario roads, which includes obviously the City of London. Perhaps more impactful on the city itself and staff is the connected vehicle aspect of this technology, which essentially would be a way of these vehicles communicating to both each other through this vehicle-to-vehicle or V2V communication, through vehicle to infrastructure. So that might be something as the signal telling the vehicle when it's about to turn green or turn red for that matter. And in a broader sense, vehicle to everything, which might include pedestrians, bicycles, and things of that nature. Also, there's the ride sharing and MaaS, or mobility as a service. So this is, you could look at it almost like the way Uber or Lyft or other technologies work, but instead of just for a single ride, it might integrate other ride sharing services, transit, bike sharing, things of that nature. So this just gives you a bit of an overview of what type of opportunities there are with those mobility of a service type of opportunities in the future. So I just wanted to make sure that we're all on the same page with this, and with that, I'd just like to introduce our three speakers. Just mention them by name, and I'll let them be a little more forthright on what they want to say about themselves. Barry Kirk, who's the Executive Director of CABCO. I'm forgetting the acronym at the moment. Edwin Olson, CEO of May Mobility. And lastly, Dr. Amir Shalabi of iCity Cats. So with that, I'll call Barry up to start us off.
To the era of self-driving cars. It started. Get the right button here. Oops, nope. There we go. CAVCO, we always use the acronym. We're a consulting company involved in helping both the public and the private sector get ready for the AV era. We are not affiliated with anybody developing the technology itself, although I talk to them. This is New York City, 1900. Every single vehicle is a horse and carriage. A mere 13 years later, there's been a revolution in transportation, and almost every vehicle is now a horseless carriage. There is one horse and carriage there, halfway down on the left, but that's the minority. A huge revolution in just 13 years. In terms of timing, where we are today is you can buy cars with what we call Advanced Driver Assistance Systems, ADAS, which means intelligent cruise control, lane keeping, and so on. And they're also in commercial use, fully automated driverless shuttles in controlled environments at low speed, and they are in fact in more popular use in Europe, actually carrying members of the public day by day. So that's the first generation. In the early 2020s, we're going to see level 4 cars, which are automated, no steering wheel, but only for use in controlled environments like downtown London. And they're being designed for driverless taxi applications. These will have no steering wheel, no pedals, early 2020s. Through the 2020s, we're going to see a rollout, increase in capability, increase in the number, and there's a technical term called vehicle kilometers traveled, and that'll increase steadily through the 2020s. In the 2030s, we will see the ultimate, and that is a fully driverless car that can go anywhere at any time in almost any weather. And let me differentiate very quickly between the 2020s version and the 2030s. In the 2020s, you would need to have an area that's geographically constrained and has been pre-mapped in great detail. In the 2030s, artificial intelligence will have advanced to the point you don't need that. You can have the car actually see where it's going and drive like a human, but better. For example, a campground. If you go to a campground and go to your trailer or your tent, the tents, the trailers, they change almost day by day. In the 2030s, that car can navigate that, avoid tents, avoid kids. There's still a number of technical challenges. I won't go through those. These are known, they're being worked on, but they are still challenges. Biggest single benefit is self-driving cars will be much safer than human drivers. A US study shows that 93% of collisions involve human error. Sometimes other factors are involved. My hope, my prayer, is that we can end up with full deployment and eliminate 80% of the collisions and deaths. But one of my things I really complain about is there's too much hype. Too many people who should know better are overhyping the technology and talking about, as Volvo does, a crash-proof car. There's no such thing. I'm an engineer. I know all hardware, all software fails occasionally. And my expectation is, my forecast is that in the future we'll have far fewer collisions, but still some. And we, as a society, need to be prepared for that. This is going to cause a real revolution. Driverless taxis are coming. In fact, they're being used now in Arizona. People are paying for a ride in a driverless taxi. Yes, there's a chaperone driver, just in case, but eventually, as the technology matures, that'll get phased out. We are going to see a merging of business plans between cars, driverless cars, taxis, transit, rental cars, and everything will get turned upside down. It'll be a lot of changes happening. The plan is you would use your smartphone and call a driverless taxi the way you now use one to call an Uber. The only difference is the driverless taxi may be provided by Uber or Lyft. There'll be nobody in it when it arrives, and it'll be a lot cheaper because at the moment, 50% of a ride to Uber goes to the driver. If you take the driver out of the equation, you can save a lot of money, and the prices will come down. As we move ahead, one thing to keep on your radar screens is pushback from the unions. This is a case in Columbus, Ohio, where they announced they're going to have a trial of shuttle buses. And as you can see from that headline, the transit union threatened to go on strike. I've started to receive hate email, literally, for advocating for driverless vehicles that will put people out of work. And I know at least one head of a major transit organization in Canada, the one thing that keeps him awake at night is the concern about union pushback and reaction. Huge impact on the city of London. And I urge you to think of all of this as not just transit and transportation, but the broad area of the city and almost every department. One of them, for example, is insurance. You've got insurance companies here. Warren Buffett and I agree on one thing. I don't know him, but we agree that self-driving vehicles will be wonderful for society, but really bad for the insurance industry. And that's going to affect things. Policing is going to be affected. Based on a US study, 53% of our interaction with the police is based on traffic, collisions, speeding, and running red lights and stop signs. If we assume that computers will be safer and more law-abiding drivers, will you need as many police in the future? And if not, do you downsize the police force, or do you reallocate them to some other duty within the police service, or more likely, some combination of that? I compare where we are today to where we were 110 years ago, when the first Model T Fords were being built. We know, looking back, how cars changed everything in the 20th century. It changed our individual lives, it changed the cities, the infrastructure, it changed society, and many people, including me, refer to self-driving cars as being cars 2.0. So we're going to see everything changed all over again. A lot of business plans are being disrupted and will be disrupted, and it'll affect almost every department in every level of government in the country. So it's a major change. These changes will start in 2020. I think by 2030, the City of London will look quite different. The early 2030s. Now, if that seems short, think about the two slides I showed you at the start, New York City. In those 13 years, there was a revolution. And 13 years from now is 2032, and I'm predicting an evolution, a revolution of equal magnitude. So I'm recommending to really have a vision of where the City of London wants to be in the future. I'm a great believer that you need to plan for the future. These changes are disruptive. They're a singularity. And you need to, I believe, not assume the future is an extension of the past, but you need to plan ahead for the future. I'm recommending you appoint a full-time in-house CAV expert. And I know the scope of the CAV working group is a work in progress. I'm recommending it be truly citywide, not just transit and transportation. And finally, for obvious reasons, I recommend your transit and your transportation master plans definitely include the impact of CAVs in all its many forms. That's the end of my presentation.
Thanks, Mr. Kirk.
Thank you.
Okay, I'll now turn it over to Edwin Olson of May Mobility.
Thanks, go ahead.
Hi, thank you. My name is Edwin Olson. I'm the CEO of May Mobility, which is a startup in Ann Arbor that builds autonomous cars. That changed on its own, that was neat. And also an associate professor of computer science at the University of Michigan. A little bit about my background so you kind of know the perspective that I'm coming from. I started building autonomous vehicles back in the early 2000s, late in the 1900s, and building autonomous underwater vehicles for the Office of Naval Research. After that, I was in the DARPA Urban Challenge, building an autonomous vehicle for MIT's team, which was one of the 5 teams that actually finished the race, which was a lot of fun. After that, there was kind of a collective deep breath about autonomous vehicles. I think the way to view the 2007 DARPA Urban Challenge is that we did it, but only just. And so a lot of the researchers in the space kind of went off to go do other things for a little while. That applied to me too. I went to work on teams of robots that would do things like collaborative search and rescue missions. So imagine in a natural disaster, it'd be really useful to be able to send in a squad of 12 or 100 robots to go and build a map of the collapsed building, beam that back to first responders. Why is it changing? I must have timings on or something. I'll deal. And be able to beam that information back to the first responders. But then the autonomous vehicle space started heating up a little bit again. As in my role as a faculty member at the University of Michigan, I joined Ford as a principal investigator on their autonomous vehicle program. So led the technical development of Ford's autonomous vehicle program. And then decided to double down again and became the co-director of autonomous driving for Toyota. So all of that, a lot of experience in the auto industry building these vehicles and seeing the trajectory that OEMs are on, robo-taxis and level 5, as we heard about just a moment before. And what I saw through all of that was chasing a problem that's not yet ripe. So I have the peculiar position of being a CEO of an autonomous vehicle company that's actually pretty bearish on autonomous vehicles, or at least I would say we need to be very sober about what the vehicles can do and what they can't do. To give you an idea, the state of the art in autonomous vehicles for a level 5 robotaxi that could go anywhere is about 5,000 miles driven for every time it makes a bad mistake. To put that in contrast, a human driver drives about 100 million miles between causing a fatality, a collision with a fatality involved. So there's a gap of 20,000 there. So if you think about that as a percentage, autonomous vehicles today are something like 0.0005 5% as good as a human driver. It's a huge difference. But at the same time, the technology can do a lot of really good things, and I was driven to try to figure out how we could bring that technology to bear in a responsible way to solve problems that are of immediate importance to transportation planners. And that led to May Mobility, which I'll talk about now. So we already talked a little bit about the safety problems. A lot of crashes are caused by humans. But another problem that really resonates with us is that there's a huge percentage of the population that is underserved by the current transportation options. It's just very expensive to get buses and other transportation services to all of the people who need them. And so being able to go with a smaller form factor that's autonomous can deliver those services to communities that are currently underserved. And then there's also the practical problem of congestion, with services like Uber and Lyft taking off that have extremely low average occupancy rates. For every Uber vehicle that you see with a passenger in it, there's between 1 and 2 other vehicles just taking up space on the roadway, waiting for the next call to come in. And so we see a huge opportunity for autonomous vehicles operating on these structured routes to be able to increase the average occupancy per vehicle and have a positive impact on congestion. So the big approach for our company, and actually my research lab before that, was to find an incremental approach. Clearly, trying to become a robotaxi overnight isn't a good idea. That factor of 20,000 is too big. So we start incrementally, lower speeds, 25 miles per hour and less, that's about 40 kilometers per hour. At that speed, you're much less likely to injure a pedestrian if you did collide. But also because you're going so much slower, you're much less likely to have a collision in the first place because you can brake much more readily. The technology is also incrementally improving. And so we look at how to develop the technology that can operate in these mixed traffic scenarios, but maybe putting off for now the gnarliest problems out there of like a high-speed rotary with 4 lanes. The regulatory side is also really important. I think it's been really clear over the last few years that cities actually have a lot of power and influence over the deployment of mobility technologies into their places. Take, for example, the scooter debacle in the West Coast, where a bunch of technology companies decided that they would just start littering the sidewalks with their scooters. And similarly, a lot of AV companies have also gone down the wrong path, I think, in terms of imposing their solutions on a city without getting buy-in. So we take a very hand-in-hand approach to making sure that we're working with the transportation planners. And learning, that's actually a real picture. I don't know if you can see that. That is a picture of one of our sensor clusters in Detroit in real weather with icicles all over it. So we love the learning process of figuring out how things can go sideways. So some quick milestones about our company. Yep. So we're a venture capital-backed company. We've raised a bunch of funds. We have deployed in 3 cities in the United States. We are live today in downtown Detroit on public roads in mixed traffic, serving a private customer, providing a shuttle service to and from a parking structure. We're also live today in Columbus, Ohio, which is the only deployment of AVs in the country where anyone can go and get a ride. You don't need an NDA or to sign a liability waiver, but it's a structured route. The vehicle drives the same loop 200 times a day. And so we're really able to tune in the vehicle to that problem. And we've delivered over 40,000 rides to passengers, which has allowed us to understand what the factors are that influence rider satisfaction. So if you're familiar with NPS scores, you've probably all filled out the survey. Would you recommend this service to a friend or colleague, rate on a scale from 1 to 10? So you take the percentage of people who would recommend it, subtract from that the percentage of people who would not, and you get your provider score, your net promoter score. And so we're at a +70, which I think really shows our commitment to building systems that our riders love to use. So I'll leave with this picture here. We're carrying real passengers, and we think this incremental approach is really the right way to bring technology and to start tapping into some of the safety and accessibility opportunities that it provides. Thank you.
Thank you.
And lastly, I'd like to introduce Dr. Emir Shalabi for his presentation.
Welcome. Thank you, Dr. Shalabi.
Thank you, Mr. Speaker. Okay, so my presentation today is going to really focus on public transit and how it intersects with those new emerging technologies of connected and autonomous vehicles and shared mobility. So first, a quick word about my background. I'm a professor of transportation engineering. I specialize in public transit planning and operations at the University of Toronto. And I also serve as the associate director of the CAT Center, which is Center for Automated and Transformative Transportation Systems. Very quickly, this center is concerned with the three themes, essentially. First is quantifying transformation, how we actually can develop tools to start quantifying the transformation from the status quo into a future with autonomous and connected vehicles, as well as shared mobility solutions. And the second theme is to develop some of those enabling technologies and service concepts that will take advantage of those new emerging technologies. And the third theme is ensuring that we have the higher order goals of sustainability in terms of the environment, the economy, and society are being served by those new technologies. So this is the focus of our center. There's 5 professors and a number of graduate students and postdocs working on different problems related to those three themes. So, as my colleagues already pointed out, that the transportation system is actually undergoing major revolution. There are major trends that are happening, we are seeing before our eyes. First is automation and connectivity. There's also shared mobility solutions in terms of Uber, Lyft, and microtransit, and other forms of shared mobility services. There's also, all those services are actually generating a lot of data that really has so much value in terms of informing the decision-making process, as well as the trend of electrification. I'll focus my talk today on automation, connectivity, and shared mobility services. So there's a lot of promise for those technologies. Some of those advantages have already been highlighted by my colleagues. So connected and autonomous vehicles and shared mobility solutions, they give more options to people, so they empower people by enhancing their mobility choices. If certain conditions are satisfied, congestion could in fact be reduced, traffic congestion on the road could be reduced, and reliability could be improved. Those technologies are designed to improve or to minimize the human error, so there's a potential for reduction in accidents. And also, all those technologies are electrified, so there's potential for reducing emissions and carbon footprint, reducing parking requirements, because we don't really need as much parking infrastructure as we need today with such technologies. And also, the road infrastructure could actually be reconfigured and we can free up some space that could be used for other purposes. And in the end, all those technologies also have a lot of potential to improve accessibility and equity goals of cities. However, those technologies also come with a lot of threat in terms of risks, unknowns, and unintended effects. So the benefits can only be accrued if we have very large penetration of those technologies and adoption of them, and also that there is shared use, extensive shared use of those resources, as opposed to personal use of those connected and autonomous vehicles. So without which, we can actually see an increase in urban sprawl, and many urban regions have actually been promoting policies to curb urban sprawl, so those new technologies can undo those effects. So we can see increase in VKT and congestion because of zero occupancy driving and deadhead trips, as well as latent demand. And all of this can also undermine public transit, that we can actually, those services can take away and draw from the ridership of public transit, making it less cost-effective and less efficient, and it gets into this vicious circle that eventually will have actually to reduce public transit quite substantially. And there's also unknown behavior of the mixed fleet of autonomous and non-autonomous vehicles sharing the same roadway. So there is still not really understood how those technologies would interact with each other and what the effect would be on the traffic dynamics and behavior. There is also going to be, although there is potential to reduce traffic accidents, but there could also be an increase in high profile and severe accidents by such technologies in some instances. For example, in inclement weather or in other difficult scenarios where the technology cannot really respond appropriately. And also the interaction between pedestrians and those vehicles on the roadway. And of course, there's major transformation of our infrastructure that needs to be in place before such technologies can be fully operational, and new regulations also need to be in place. So the evidence, and this is all based really on what we understand about the technology, but we have some evidence thus far in the form of ride sourcing. Uber and Lyft have been in operation in a number of municipalities across North America. Numerous studies have looked at the impacts of those technologies. So in terms of auto ownership and VKT, there has been numerous studies that have shown that the introduction of Uber and Lyft have not actually reduced auto ownership, and in fact, they contributed to more congestion in, for example, San Francisco and other places. So increase in traffic congestion and greenhouse gas emissions in large cities, an increase in commute times and congestion, especially in contexts with there's no other alternative. So public transit is quite poor, so those services cause more congestion. And transit ridership, we've done a recent study for the Canadian Urban Transit Association looking at all transit agencies in Canada over the past 15 years, looking at the effect of Uber and Lyft, and there was empirical evidence to suggest that that Uber and Lyft actually impact negatively transit ridership, especially in small cities. It can have a positive impact on high-order transit like metro, LRT, and BRT, and this has been shown in a number of studies as well. So those services can serve as first mile, last mile, and consequently, they can improve public transit ridership. So coming to the end of my presentation, public transit, or specifically higher order public transit, when I say higher order transit, I mean metro, LRT, and BRT, have been shown to really to be the most space efficient of all modes, so offering the highest person capacity for urban corridors. So in this slide that you see before you, if we have 50,000 people that we would like actually to transport through one corridor, you can do this with an outrageously wide road of 175 meters if all the transportation is done by personal cars, or a single metro line could do the job with 9-meter width, and in between you may have LRT and BRT who might require a little bit wider space to serve the same number of people. The point is that public transit, especially higher order public transit, is very high, is space efficient. It has a very strong record in reducing congestion if it's done right, and also reducing traffic accidents. If a lot of people use public transit, the number of accidents per capita is reduced quite substantially, and that has been shown in numerous places. So the public transit is really the ultimate form of shared mobility. So when we talk about shared mobility, the first thing that jumps to mind is Uber and Lyft, but really public transit and properly designed public transit is the ultimate form of shared mobility. Therefore, the transit community, and specifically the UITP, which is an association of all public transit companies around the world, have articulated a vision for public transit in the context of connected and autonomous vehicles, seeing that There is a role for such technologies to play to fill gaps where conventional public transit is not really very effective. So in low demand routes, for example, to serve as shuttles between stations, to serve as first mile, last mile service for point-to-point, short point-to-point trips, and so on. Those technologies have a major role, but they need to be integrated with public transit such that we maximize the benefit for the whole city through an integrated mobility system. So this is the key word here, integrated mobility system. At its core is public transit, supplemented by other technologies. And UITP has also advocated for putting policies in place to encourage shared use connected and autonomous vehicles so that we can get the best benefits out of those technologies. So with this, I conclude my presentation. Thank you very much.
Thank you.
Thank you. For the next portion of this presentation, I'll be asking 5 frequently asked questions, like I think I mentioned before, talking about different themes that we see in the industry with autonomous vehicles and ride sharing. So I've mixed up the order a little bit with everybody. I'm going to aim to give everybody 2 minutes to answer. So hopefully once we get through these, we can turn it over to the members here to ask their general questions, all right? So the first question I'd like to ask is, what can you tell us about likely timelines for the commercialization of autonomous transit technologies? And we'll start with Mr. Olson.
There we go. So I think the timeline for autonomous vehicles is going to start slow and build slowly until we're probably pretty done and moved on to other things. So I think that timeline has started. I think it started last year. We were earning revenue with autonomous vehicles on very structured routes last year. And so I think that starts the beginning. I think by the time that we are looking for level 5 vehicles, those are the vehicles that can go anywhere, anytime, under any condition. There are technical challenges there that cannot be solved with even reasonable extrapolations of the current technology. So, for example, approaching a police officer in the road who is motioning with their hand and telling you, to get 3 lanes over, but, with all the rich communication, we don't know how to do that. That's not a matter of stick another PhD student on it and do it. It's that the technology we have doesn't lead to a solution to that problem. And so I think that level 5 future could be 2040, 2050 even. It's going to require a lot of work.
Okay, Mr. Kirk, please.
One of the problems is when you get 3 experts together, you'll get 3 opinions. And I half agree with my colleague, Mr. Olson. I agree that the AV era has started. I agree it'll ramp up slowly. But I believe the level 5 vehicles will be available, commercially available, for both cars and transit by about the mid-2030s. The 2 implications of that. One is my suggestion is that the City of London's vision for transit in general for the 2030s and beyond should be looking ahead at a fully automated transit system. I believe the technology will be there then. And linked to that, robotic technology is advancing very quickly, so is artificial intelligence. Some experts, not me, some other experts believe that by about 2030, there will be a humanoid, an android robot, that will be able to climb into one of your old-fashioned 2019 era buses and drive it like a human, or maybe better. So that's the way the technology is evolving. I see it. I'm obviously more bullish than Mr. Olson.
And Dr. Chalabi, please.
Yes, starting with automated technologies for public transit, I think, in my view, that this is more advanced than the general personal cars or small cars. We already see autonomous shuttles, and we've seen an example here by my colleague. There's also a number of pilots for full regular buses, 40-foot buses, for example, by Mercedes-Benz in Schiphol Airport for level 3, I believe. I've seen the pilot myself. There's also pilots in Singapore for regular routes with full buses, like 40-foot buses. So the technology is there, and it's easier to deploy those on public transit right-of-way, dedicated right-of-way, because it's less complex environment. For personal cars or for passenger cars that are automated, I think the forecasts differ a little bit. So some forecasts are that level 5 or level 4 will be 2030, 2035. Other forecasts are a bit later than that. So it's really very hard to tell with the state of the technology.
So for our second question, how do you see London's transit system and future rapid transit interacting with autonomous systems, microtransit, and or ride-sharing services when they become more commonplace? And to start off, we'll go back to Dr. Shalabi, please.
Well, I probably can repeat some of the points that I made in my presentation, that we envision, a lot of transportation planners and specifically transit planners envision an integrated mobility system with public transit, or the main routes to be served by, or main corridors are served by public transit. And then you have autonomous shuttles or different other technologies and shared mobility solutions that could serve other areas and also at other times. So for example, now Uber, we see that the peak time for Uber is Friday night and Saturday night. So those are times when public transit is not really very cost effective, and such times and locations can be served much better and more cost effectively by shared mobility solutions and connected vehicles.
Mr. Kirk, please.
It's impossible to actually design the future City of London transit system in just a few minutes, and I won't even try. One of the things I do want to focus on is not so much the technical aspects, but the business plan. One of the realities in New York City is the Metropolitan Transit Authority, MTA, recently issued a report that shows that their transit ridership has gone down 12% in the last few years, which exactly matches the increase in ridership of ride-sharing services like Uber and Lyft. So we're already seeing the start of a shift over to ride-sharing. In the future, when Uber and Lyft and the others use computers rather than drivers, the cost of those rides will go down, and we can only expect that trend to accelerate. The impact on the City of London is that past ridership figures are no guide. And there will be competition from ride-sharing services, which may well decrease ridership revenues, which would increase the operating subsidy paid by taxpayers for the rest of the century. So there's a financial risk there that obviously needs to be analyzed as part of the next transportation transit master plan.
And lastly, Mr. Olson.
A transit system is a pretty complicated thing. There's a lot of different modalities with their own strengths and weaknesses. If you have as I know you guys are discussing a BRT line, if you have a route that is a good fit for a BRT line, that's it can be an amazingly efficient thing to do. At the same time, trying to solve everything with a BRT line is not going to work either. So even while I'm sort of bearish on AVs in terms of level 5, though I think the one thing I would want to leave you with is that the places where autonomous vehicles make sense today they can offer tremendous advantages over traditional services. It's not everywhere, it's not every time, but when you have a route with the right sort of ridership, with the right speeds and the right road structure, those vehicles can provide a 3 to 6 times performance improvement over a traditional bus on a dollar for dollar basis. And so I think the transportation planners need to be empowered to mix and match technologies that are going to provide good service and start to reverse the declining ridership, declining service vicious cycle that affects most transit agencies.
Thank you. And for question 3, a recent San Francisco study showed ride-sharing companies accounted for a significant portion of increased congestion. What can the City of London do to manage potential negative impacts of CAVs and ride-sharing, including increased congestion and zero occupancy miles? And I'll start off with Mr. Kirk, please.
That's a very interesting study. And yes, one of the paradoxes here is with microtransit, there is a real likelihood there will be increased congestion. For all the reasons mentioned in that summary of the study. The secret sauce to prevent that, to minimize that negative effect, is to encourage ride sharing. And there are, incentives, financial incentives, travel time incentives to try and encourage people. So if, for example, where I live out just outside Ottawa, if I were to take, and if all my neighbors on my street were to take their own separate microtransit vehicle downtown, that would be very bad for congestion. But if you can encourage myself to team up with, a couple of other people near me, and we were to share one of these shuttles downtown, that would be wonderful. And one of the ways to do that is, for example, to encourage, to make available any transit or HOV lanes so that people can get downtown quicker if you've got multiple people in them. So I'm bouncing back to the council to encourage ride sharing. That's the best way to minimize the negative impact on congestion.
Dr. Shalabi, please.
So I think a set of incentives and disincentives would be very effective, I think, to minimize really the negative effects of on congestion and zero occupancy miles. So integration between those services with respect to physical integration, fare integration, and service integration of all those shared mobility like Uber and Lyft. So if we can provide, for example, preferential treatment for such services at stations for pickup and drop-off, that would encourage and promote the first mile, last mile service to people, as well as if there's also financial incentive. If I take both public transit and Uber, that again would really incentivize really the trip to go all the way to downtown, but instead to just go to the nearest BRT or metro and then go take that to downtown. Also, bylaws to prevent zero occupancy bylaws, zombie car bylaws that can also be put in place to try to curb this trend.
And Mr. Olson.
I'll put a couple numbers in your head, which I think are fun. So average occupancy of a street vehicle in New York is about 1.1. So a little over one person traveling on a vehicle. That's including buses and high occupancy vehicles. That's terrible, right? That leads to a lot of congestion. Obviously, a personally owned vehicle is going to be 1. So we're just barely better. A ride-hailing service like Lyft or Uber has an average occupancy of about 0.3 to 0.5. So what that means is that for every Uber that you see carrying a passenger around, there's about 2 more Ubers driving around empty. So the challenge here is I think we have a lot of evidence that in most cases, bus systems don't attract enough ridership, and so you have to be able to attract people to the ride to those services. You can't have just the underserved people riding the buses because that's their only option left. You have to make it a first choice for people who can afford not to take the bus. And to do that requires providing an exceptional level of service that is totally unlike what any bus service looks like today. Near zero wait times, comfortable seats, places to work, places to where you can put your laptop out. And our belief is that doing that with small vehicles that provide sort of a personal space that seat up to 5 or 6 is a way to do that. We're not shooting for average occupancies of 20, 50 people on a bus, but if we could do 3, an average occupancy of 3, that would be a huge win.
Thank you. Question 4 now. Let's play devil's advocate. What are some of the major technical limitations and hurdles yet to be overcome by autonomous vehicles, and when can these expect to be solved? And we'll go back to Mr. Olson for that.
I got to beat up on my own company now. No, there are lots of technical challenges. I think speed is first and foremost. At higher speeds, you need to be able to see farther in order to have enough reaction time. Seeing farther means that you need longer range sensors, which, if they exist at all, are prohibitively expensive and ruin the unit economics of the vehicle. Then there's all of these sort of, if you lived in a world where all you had to do was to react to stoplights and stop signs and pedestrians and other cars, that would be a blissful, easy world. It's all of the weird things, like the traffic cop who's manually directing traffic, overriding the traffic light that says green up ahead and has his hand out to tell you to stop. Those are really thorny problems. A bit of relief, though, is that we don't have to solve those problems perfectly in order to make AVs deployed in a more widespread way. It's possible for those cars to essentially phone home and go to, ask a remote call center or remote operator, hey, looks like there's a police officer in front of me and he's waving his hands around. I don't know what to do, but maybe the call center can help. And so we're looking at those kinds of options, but it adds delay. And so if the car has to do that every time it's in a thorny situation, you end up with a vehicle that's not usable.
Dr. Shalabi, please.
Yeah, there's a number of known technological challenges, like, for example, operating in inclement or adverse weather conditions, also without clear lane markings, and also some reported problems with going over bridges and so on, are some issues. In my mind, the coexistence of autonomous and non-autonomous vehicles in the same right-of-way presents a technical problem from traffic engineering point of view. The traffic flow, managing traffic flow that is really mixed, both autonomous and non-autonomous, is something that really presents a major challenge. There's of course the sensor software and processors that are really part of the whole ecosystem of autonomous vehicles. Those are not without problems. They can fail, and if they fail, especially in some conditions that are not favorable, those definitely present major challenges. Thank you.
And Mr. Kirk.
Thank you. I'll give you 2 very quick ones, 1 minute each. One is hand signals. I don't mean the rude variety, but what I do mean is when I go home, near my home, there's a 4-way stop sign, and I turn left. And if I see a car coming towards me and we both stop at about the same time, I'll do this, and the other driver sees that, he or she comes ahead and I turn left and everything's safe. At the moment, the technology is not very good at peering through a windshield and interpreting that kind of hand signal. The other quick one is pedestrian prediction. If I see somebody walking along, looking at their smartphone and approaching the road, are not paying attention, then I know enough that they may walk onto the road and be a hazard to them and to myself. So it's harder to, at the moment, to train the technology to recognize that a human looking at a smartphone is a potential hazard.
Thank you. And for our final question, number 5, where do you see the integration of autonomous vehicles and ride sharing into society over the next 1, 2, 5, 10, and 20 years, including mobility as a service and I guess more of a contentious shared ownership versus private ownership models? And for that, we'll start with Dr. Shalabi, please.
I believe there's going to be a transition, really. We cannot adopt those things pretty fast. We need to take a cautious approach of implementing those and assessing really how they work, where they work well, and what we can do to improve their performance. And those pilots that are being implemented in a number of places around the world, I think a very good first step approach to start introducing those technologies, gather some data, see how does such technology work. So I think over the next, I can only predict over the next 2-3 years that we will see many more of those pilots, not only autonomous vehicles, but also connected vehicle technology or vehicle to infrastructure technology where the vehicles can communicate with the traffic signals, for example. So we'll see more and more of those pilots towards more wider adoption and implementation of such technologies afterwards.
Mr. Olson, please.
I think 2 things that everybody should know about today's AV vehicles. They're really expensive and they require a lot of specialized care and feeding. Those 2 facts basically mean that there's not going to be privately owned AVs anytime soon because it's not going to be worth it to you to buy a $500,000 vehicle and hire the 2 technicians to maintain it every day. So for the next 5 years or so, we're really looking at a future where these fleets are built and maintained by companies that can keep those assets in constant motion. That means sort of a ride sharing or mobility as a service type of model is really the only one that economically makes any sense. 10 years, 20 years on, it's possible that the technology will be cheap enough for personally owned vehicles, but I'm hoping by then we don't have them and that everything is migrated to mobility as a service anyway for the accessibility and equity and congestion reasons.
And finally, Mr. Kirk.
Once again, Mr. Olson, I disagree. One of the realities of the switch from internal combustion engine to electric battery and drivetrain systems, they don't make it much simpler. An average internal combustion vehicle has about 2,000 moving parts. An average electric vehicle has about 20. They're going to be similar to maintain, but they require a different kind of technician. The vehicle technicians of the future have to be more than be familiar with diesel and hydraulic systems. They'll have to be retrained for electric battery and drive systems and a lot of software. I know in the average case of an average car, at the moment, if you buy a new car, between 5 and 6% of the car's value is software. By the mid-2020s, software will amount between 40 and 60% of the value of a car. And that's going to be a big change in technician. And people, I do agree, people will generally not be buying them, but they'll be buying rides from an Uber or Lyft or similar kind of company.
And with that, I just wanted to thank all our speakers for participating in our panel. And I'd like to turn it back over to the chair and open it up to the members to ask their questions. Thank you very much.
Thank you, Mr. Kosniak. So I will look to the working group members. Councillor Squire.
Thank you very much for coming. I appreciate the presentations, but I want to bring you, I hope I can bring you back to the decisions that have to be made in London. London has been, the environment we're in, at least from my point of view, and others may disagree with me, we have anecdotal dissatisfaction with our present transit system. We have a huge buy-in to ride sharing, whether it's 1 or 2 passengers, to the tune of 1.8 million increase in rides per year. And a lot of young people saying, I like Uber, I like it, it's sexier, it's easy, and I'm gonna take that over transit. We have a proposal on the table that was approved by the previous council for a BRT system. BRT system. We now are going forward to a series of meetings where a $500 million is going to be on the table, and we're being asked how to spend that money. I don't want you to tell me specifically how to spend the money because you probably haven't been in London long enough, but I want you to tell me what I should be looking for in the transit proposals that come to me as an elected official in the next month or so. What should I be thinking about when I make that vote and make that decision? How do I look to the present and look to the future?
The number one thing you should think about is, will the level of service be high enough to draw riders? And the challenge is that riders are very sensitive to poor levels of service. If wait times are over about 10 minutes, you start to lose ridership. And so, you know, I think it makes a lot of sense if you're going to do a BRT to go big and make sure that the level of service is going to be high enough. Doing it in a half serious way is just likely to be a total failure. I can tell you that our median, our rider satisfaction numbers are driven almost entirely by wait time. We have a median wait time of about 1 minute in Detroit, and our riders love it. I think the reality is, you can all imagine, if you only had to wait a minute for a bus to take you where you wanted to go, that starts to look awfully attractive, and you start looking at your car like an anchor around your neck. But 10 minutes, 15 minutes, 20 minutes, I'll just hop in my car.
Anybody else? Dr. Shalabi, you want to go ahead?
I think in the end, it's really a question of road capacity. I mean, if without a dedicated right-of-way, so how many cars and buses, like in the status quo now, would be required to transport the number of people at a certain reasonable level of service? So if the answer is, I mean, for those particular corridors, that really the volumes now of public transit are pretty high, replacing or really pitching an alternative to BRT, such as shared mobility and so on, we don't really have the road capacity to serve all those people being served in cars, in passenger cars. And that will inevitably really increase the road congestion and greenhouse gas emissions and other things. So, I mean, for high demand corridors, where, for example, let me put some numbers. I mean, when we're talking about passenger volumes of about, exceeding 10,000 passengers per hour per direction, I can't really see how you can serve that volume of people in passenger cars and not really in high speed, in high performance public transit mode.
Mr. Kirk.
5 years ago, 2 things happened. One is you started working on the BRT planning for real. I know the concept was a bit earlier, but a lot of the detailed work started about 5 years ago. And 5 years ago, I started talking about studying and talking about self-driving cars. And 5 years ago, people thought I was a nerdy geek who'd overdosed on science fiction. And a lot of things have happened in the last 5 years about self-driving cars, and you've heard about them this evening. I think the one thing I would strongly recommend is, before you get too involved and spend too much money, just revisit the vision of what you want to achieve, your vision for transit in the City of London in, let's say, 2040, and how you're going to get there. And that, having that vision will really help inform you about the short-term decisions. Because I think the present version of the BRT is based on what was very valid 5 years ago, but a lot of things have happened in the last 5 years.
Thank you. So the way I'm going to do this is because there are a lot of us and three panelists with quite a lot of information to share. I'll allow one question per member of the working group, and then we can go back again to the start. Is that all right?
Yeah, okay.
Absolutely.
I just want to thank you. That's really helpful and interesting. And I really, it's valuable to me in my decision-making moving forward, so thank you.
Councillor Hopkins.
Thank you very much, and I too would like to thank you very much for the presentations. I found them very informative and very interesting as well, and I do appreciate the different points of view. And if anything, I understand that weather here is a consideration, an important consideration, and convenience as well, and how we integrate the system here is we need to hear all different sides. And I've got one question here, so I'm going to pick my question right now. And I'll ask Mr. Kirk, because I really think what you said about the vision is really important. And we have been talking about improving the transit system here for quite a long time, a number of years. And as we move forward, how we envision it to me is really important to be part of this conversation. And you talked about the need for the infrastructure to be put in place. The municipalities should be looking at the infrastructure for these driverless vehicles. And I wonder if you could just expand a little bit more, what should we be looking at or considering within our vision and where we are in this space in time?
A very good question. When I refer to infrastructure, I think more of digital infrastructure and not physical. I believe that no place in the country can we afford to put in new physical infrastructure everywhere just for AVs. The cost is too tremendous. No combination of companies and governments can afford it. We're going to put money into the vehicles, the sensors, the software. And what we do need, though, is digital infrastructure for the communications between the vehicles. What's going to be very important, especially early on, is the ability to download a new operating system to the cars, and that will happen on a fairly regular basis. Download new driving software, download information about traffic and weather to help with routes, and also, because people in the car will have more spare time, download infotainment, information, entertainment, and all of that will require infrastructure. And the new one that's used, mentioned a lot, is 5G, the next generation of cell phone technology. There's a lot of work going on with that worldwide, and that 5G and variations of that will be the dominant way of getting information to and from the vehicles. I was talking about downloading. The other part is uploading information from the vehicles, from the sensors, in different ways. So it's digital infrastructure, Councillor, and not physical.
I wonder if Mr. Olson or Dr. Schlaby want to chime in on that at all?
So I think the BRT proposal has a lot of physical infrastructure associated with it. The types of renderings that I saw I guess one of the questions would be, suppose you build it, and for the next 12 years, let's suppose it's the greatest, it works great, but then the AV level 5 vehicles are here. Have you just wasted $500 million and now is that infrastructure useless? I think the answer to that is a big no. I think that the types of infrastructure that are proposed for typical BRT are actually quite suitable for AVs as well. Would every single thing be needed? Probably not. But I think I'm also very concerned about you still need the higher speed, higher throughput corridors that the smaller autonomous vehicles can complement. So I don't think it would be entirely wasted, but that would require looking a lot more closely at the specific proposal.
Great, thank you. Now I'll go to Ms. Ruth.
Thank you, through you, Madam Chair. We've talked a lot about Uber and Lyft. We haven't really talked about taxis, and that's a big industry in London on top of Uber. And I'm looking at the impacts that Mr. Kirk presented, and they were quite eye-opening. Some of them I hadn't even considered. So the loss of our parking revenue and the changes to our transit and the city revenues that we would lose. And I understand that we could use that parking space and put development on there, and there'd be some property tax and some development charges here and there. But what concerns me is what happens after that? After that parking lot is now a building and we've collected the money from that. How do we pay for all this infrastructure when we're adding all of these new vehicles onto the road? We have to create this new infrastructure, the digital infrastructure that you've just mentioned. And when I look at Manhattan and their taxi rates, before the car even moves, it's $6.30. And $6.30 is all surcharges. So there's an improvement surcharge, there's a rush hour surcharge, there's a congestion surcharge, and a $2.50 flat rate. That's before you pay the 50 cents for every 1/5 a kilometer or every 60 seconds. So looking at this moving forward for Uber, or if Lyft comes to London, or our own taxi industry, how do we collect any revenue to make this infrastructure work and continue sustainably?
Another very good question. When I think about digital infrastructure, there's two components to it. One is the 5G infrastructure, and that would be paid for by the cell phone companies. And there's a lot of work going on worldwide in terms of 5G and cars. There's a global working group called 5GAA, which stands for 5G Automotive Association. All the major car companies, all the global wireless communication companies are members of that, and they work together to develop common standards and best practices. And that includes the sort of things we've been talking about. So for that 5G infrastructure, the City of London would not pay for it. What you would pay for, if you want to have communications between the vehicles and your traffic signals, there would be a charge. That would be your cost. And that's something that's being looked at. I know here in Ottawa, where I live, there's a new test bed being launched officially next month with a grand opening, and they will be testing 5G communications to traffic signals. And on this test bed, the traffic signals are being installed by the City of Ottawa, and the 5G, the cars will be provided by BlackBerry QNX, and Nokia and Siemens will be working on the 5G component, and all of that being done in the confines of a safe, secure, private, it's government-owned test bed, but there's no public around, so there's no public safety concerns. So there would be some costs for things like the links to the traffic signals.
Any other panelists want to add to that? Okay, great, thanks. Councillor Van Holst.
Thank you, Madam Chair. So my question to the panelists is, how are people going to embark and disembark on these vehicles, or what's the best way to do that? Right now, we're looking for a BRT, lanes in the center with big stations 700 meters apart. Is that what we're going to want in 2030, or do we want something on the side that's different? So what would be the best vision for that?
If we're talking about shuttles, if we're talking about driverless taxis, those would require less infrastructure. One of the big decisions that the City of London will have to make as you move forward, and this is all part of the vision, is what is the role of the City of London in this transit vision for the future? Do you want to stay in the traditional transit business and let Uber and Lyft and others get involved in driverless taxis, and the shuttle companies, like my colleagues, get involved in running the shuttle buses? Or do you see London Transit getting involved in all the different kinds? That's a big decision, it's an important one, and if you choose to stay with the big vehicles, the main route, and leave the others to the private sector, then obviously you would not be, your physical infrastructure requirements would be very similar to what you have planned now for the BRT, and let the private sector worry about any special infrastructure. There wouldn't be much by comparison, because it's a thin route service, but it's your responsibility will depend on what kind of role you see for yourself in the future. And that's going to be a decision that a lot of different municipal transit authorities will face.
The loading and unloading of passengers, what we call actually the dwell time, so the time a transit vehicle dwells at the station, when you add all this up along the route, that takes up about 25% of the total operating time. So 25% of the time a bus spends going from one terminal to the other, 25% of that time is really spent serving passengers, getting on and off. So BRT stations are designed in such a way, I mean, they are big, but they are designed in such a way and they are elevated to allow for level boarding and lighting so that we can actually try to minimize this time and speed up the operation. But if passengers have to mount and dismount with some level differential, that adds up to the dwell time. Even if it's like 1 second per person extra, that really adds up very quickly. And so the design of BRT stations is done that way, essentially to try to minimize the dwell time and speed up the operation, which really has benefits for both passengers as well as the operator.
Oh, good. Okay. Councillor Lehman.
Do you envision a time when we will have transit giving a service of point to point? I.e., people would order a transit, it would arrive in a time frame, maybe a 15-minute window, drop me off at a specific address within a time frame, but on the way, pick up and drop off.
The simple answer is yes, definitely. I think traditional transit, and to be a little bit harsh here, I think traditional transit is very 20th century. It's fixed route, fixed schedule, and frequently multi-mode. You need 2 or 3 or 4 different modes to go from where you are to where you want to go. What you're talking about, Councillor, is, I think, far more 21st century, and certainly with driverless taxis, and I think with shuttle buses as well, it'll be a door-to-door service, on demand, flexible routing, single mode, door-to-door, and the work that's gone on already in places like New York City shows that there's a real benefit, and people are willing to pay a bit more for that kind of door-to-door, single mode service.
Well, BRT is actually designed with this in mind, to really try to minimize the access time. So you have a dedicated right-of-way, you have multiple branches that really pick up people from different places. Again, not really from your doorstep, but from a station nearby or a bus stop nearby. And then that branch, that bus will actually go to the trunk, which is the dedicated right-of-way, deliver you to downtown or... So again, it's not really door-to-door, but again, envisioning a scenario where we have everybody is being served in small vehicles, door-to-door, that will add a huge amount of traffic on the road, will add to congestion, add to greenhouse gas emission. So we need to find really a balance. So there are some places and times where such a service could be provided, but there are certain locations in downtown, for example, and high volume corridors, it's not really efficient to serve very large number of peoples, all going to work and going to school and so on with limited occupancy vehicles.
Mr. Olson?
I think the rider satisfaction is again, the most important factor. If it's inconvenient to use the service, then people aren't going to use it and it's going to fail. I think that creates a large pressure to do point-to-point. However, I also agree that that creates problems with scalability and the comment before about where are you going to alight the passengers. And it may not be that you can actually just be picked up or dropped off anywhere because the infrastructure may make it necessary for you to only be picked up or dropped off in designated loading areas. Otherwise, you might be clogging a whole traffic lane. So I think I agree it's going to have to be a balance, but I think with an eye towards point-to-point being available whenever possible for rider satisfaction and also access and equity reasons.
Thank you. Just an additional thought. Two quick thoughts. There is a compromise. One of the visions that's being promoted out there is the idea of pods, individual pods that will pick you up at your house. Then as these pods head downtown, they physically join together to form a train, which is a far more efficient use of road space. It's a concept. They've got fancy graphics to demonstrate this. And so you get some of the benefits of both, far more efficient use of the road space, but the benefit of door-to-door. And even when you get close to downtown, the pod that you're in can separate from that train, and then the remaining pods close up. So one of the visions out there, which is still quite a few years away, does that. And I'm also going to disagree again with my colleague, the professor at the end. He spoke about GHGs. Generally, these will all be electric vehicles. So zero emissions. So the question of GHGs is not really relevant, I think. But his other arguments about congestion are valid.
Okay, do I have any other speakers on first round? Mr. Khan.
Thank you very much, ma'am. And thank you very much for the very informative presentations from all three. I have actually three questions, but it will take only that time, which will take like one question. So my first question from Engineer Barry. So driving is a very complex task. And it is also said that for a complex machine, there is nothing complex. And we as a human are as a very complex machine. So when it comes to eye contact and compared with the sensors, radars, and the lidars and all the gadgets. So my question is, you must be aware of the accidents of AV and connected vehicles. And what are your findings that in 3 out of 4, the 3 vehicles, the pilots were killed, and the Uber's case, pedestrian was killed?
Those tragedies are very unfortunate. As I mentioned earlier in my presentation, even though we want to minimize collisions and deaths and injuries, they will happen, which is sad. And what doesn't get mentioned is how many people get killed in human collisions. The public has an expectation that humans are fallible, but that technology and computers are infallible. At the time of that tragedy in Tempe, Arizona last year, the day after, in one morning, I did 9 live radio interviews coast to coast. There's that much media interest. Now, if a person had been killed in Arizona in a regular traffic collision by a human driver, it would not have attracted the same degree of scrutiny. And that's why I've been really focusing in many of my other presentations about being realistic. Linked to that, one of the things that concerns me is this mixed environment. When we've got humans and computers on the same road at the same time, that is dangerous. The work that's been done by Google shows that a human driver, when he or she sees a self-driving car, is far more aggressive. And in fact, a human driver has a tendency to cut off a self-driving car at an intersection in a way he or she would never do with a human driver. And in the case of the people who got killed in Arizona, in Florida, there's another angle. Those were not truly self-driving cars. There was supposed to be a chaperone. And sometimes people trust the technology more than they should do. In the case of the Florida fatality, the person was in a Tesla, which is not a self-driving car. It's very unfortunate that Tesla calls it autopilot, because it's not. It sends the wrong message. But that guy in the Tesla was watching a Harry Potter movie when he should have been paying attention. And one of the trends we're seeing is a recognition that expecting humans to pay attention and do nothing is bad, because humans are very bad at paying attention while they're doing nothing. The sooner we move to fully self-driving cars and take humans out of the loop completely, the safer it will be. So it's a complex answer, but that's what I think.
So I'll go to Councillor Helmer now.
Thank you. I really appreciate the presentation. When Councillor Van Holst brought up this idea, I had a feeling we get a good group of people together and learn some things, and we certainly have. In terms of questions, we have seen a pretty significant increase in the number of vehicles owned and registered in London. You know, even just from 2011 to 2017, we're up to something like 278,000 vehicles owned and registered in the City of London. It's obviously very expensive to operate those vehicles. So in terms of the sort of cost of ownership of vehicles and the cost of mobility, a lot of what I heard from you was that it's going down. You know, it's going to be electric instead of fossil fuel-based sources of power. Maybe we don't have drivers in professional situations, so the cost is starting to drop down. You don't necessarily have to own your own vehicle. You can use this mobility as a service, as a way. So is it fair to characterize that as that's an overall trend that you're seeing the cost of mobility is headed downwards?
Okay, there's the upfront cost of owning a vehicle, and there's the running cost. So travel behavioral research has shown that when people make decisions about driving or not, they are not actually factoring in the upfront cost. It is the operating cost. And that's why when we price public transit, we need to keep this in mind, that our competition is the car, and we need to price transit in such a way that is competitive with the operating cost of cars. So when it comes now to autonomous vehicles, as far as I know, the upfront cost is going to be high. Same thing with buses, for example, battery electric buses. They are, I think, about $1.2 million, as opposed to a conventional diesel engine bus, which is about $600,000 or $700,000 thereabouts. But the running cost might be different. So I just wanted to make this distinction between the two.
I'll toss in a quick factoid. I think one of the things that has really distorted the cost of transportation in recent years is the availability of Lyft and Uber. It's important to point out that those are massive money losers. Those markets are are only propped up through massive subsidies from the companies themselves. And so, like in a comparison to a taxi, someone had mentioned a taxi before. The reality is that the Lyfts and Ubers are really at an unfair advantage because the companies operating them are willing to lose $1 billion a quarter to prop up that market. And so I think right now we live in kind of a weird time where it's actually hard to get a straight figure on how much the cost of transportation is because of these sort of strange economic subsidies that are in place.
My answer to your question is yes. A while back, we at CAVCO did a joint report with the Conference Board of Canada, and that report shows an average Canadian family, if they sold one car and used driverless taxis, that family would save $3,000 a year. That report's on our website. It's free, and if you're really interested, you can download it or I'll send it to you.
Nobody else on first round? I'll come back to you. Councillor Van Holst.
Thank you very much. So we've got a situation on Richmond Street where we've got 4 lanes of traffic, and we want to take 2 of those to make a dedicated lane, which will is a big concern to people because that's taking 50% of the space away for a vehicle that's just going to be on there once every 10 minutes. The question I'm interested in asking is about the service levels. Now, when I'm driving, I want the most direct route to where I'm going. When I'm on a train and working away, or I don't really care. So, do you see that in the? I guess this question is directed through the chair to Mr. Olson. On your vehicles where you're providing some other service or there's other things they can do beyond Wi-Fi, are people concerned as much about the speed as arriving? So for instance, could we send them on a slightly longer route that's off those and they would be fine? Or are they still interested in seeing that they're taking the most direct route?
I don't know the answer to that. Today, the routes that we operate on and that we have rider acceptance data on are fairly short routes in the first place. So we don't have a lot of experience with people getting deep into their novel or on their laptop. What I would say is that in terms of removing traffic lanes for a bus lane, your transportation planners, I'm sure, are doing the analysis of how convenient is that route. Obviously, you can move a ton of people with the BRT line, but if that route's not actually convenient to where they're coming from and going to, then that's not a great solution. So it really comes down to getting the data on whether people would find that to be a convenient service. That didn't really answer your question, but it's the best I can do.
Councillor Squire.
So I want to go back to something that's sort of basic to me and something I talk about all the time is the ridership increase that we might see from this huge investment in money, and is it going to happen? Is it going to actually happen? The reason I'm asking you this is because we had a panel before, and there was a gentleman from Winnipeg, and I said, since you've had BRT, has your ridership gone up? And he said, yeah, it's gone up 12%. So I said, that's amazing. And I said, will you send me the stats? And he never did. I sent him an email and he didn't send it. And then I went on their site and found out since they had BRT, their ridership had decreased. And I've never spoken to the man since. So what I want to know is if we're all in on BRT, we throw all our money into BRT and invest the increased operating costs to get the kind of frequency, Mr. Olson, that you've said people like, will we see the increased ridership, or is that a bit of guesswork, which I suspect is it sort of a invest and hope issue? Because I hear a lot of people saying, oh, if you do that, this will naturally happen. And I would like a straightforward answer. Is that predictable, that ridership will go up a certain amount if you put in a certain system?
We have a route where we have a near perfect alignment that the people where they're starting from and where they're going to are exactly on the route. And that makes that route perfect in terms of convenience and accessibility. And on that route, we have seen increases in ridership of 50%. what I can't answer for you is whether the BRT routes that are proposed align well or align poorly with where people are coming from and going to. You could have a BRT line that runs every 30 seconds, so 0 wait time, but if it's not convenient to where people are coming from and going to, then you're not going to see the improvements in ridership.
Mr. Olson, that's the most honest answer I've ever had to that question.
Would any other panelists like to provide a response? Go ahead.
Yeah. So the sources of new ridership, ideally speaking, would actually come from people who are previously have been driving by themselves and or driving and switching to public transit. And there's a number of factors that affect that, and that's what we build so-called mode choice models that really predict the probability of people choosing which mode based on a number of factors, including the level of service characteristics, as well as the socioeconomics and demographics. Because there are certain segments of society that we call auto-captives. No matter really how much you improve public transit, they will not switch to public transit. And you also have the transit captives, but you have the segment in between that are willing to change modes if you provide a better level of service at a more competitive cost. And the experience has been in many BRT systems around the world that when you provide high level of service through BRT by having higher frequency, faster service, designated waiting areas at stations, and so on and so forth, and TSP, transit signal priority, en route, and so on. So you improve the service, and it actually it builds the ability to attract people to public transit. And that has been shown in many places.
Mr. Sorry. No, you can finish.
No, there is actually a website called the BRT Institute. You can look it up. I can send you the link. And it documents all the BRT projects around the world and the effects of those projects on ridership.
And thank you. And I just want to remind everybody to please go through the chair. Mr. Kirk?
Thank you, Madam Chair. No additional comment.
Mr. Khan?
Thank you. Through the chair. My question is to Dr. Shalaby. And we know that level 5, I know that those incidents were with level 2 and level 3, but let's say level 5 is coming. Olson says that, okay, it is coming in 2050, it's a cautious approach, and Engineer Kirk says it's next 10, 15 years, it's good. So my question is that when these companies will be coming in to market to sell their vehicles, so they will be coming with the features and other selling points. So shouldn't cities within the Canada at least should start to make their own wish list? So those cars should comply with the certain criteria defined by the respective city?
Two thoughts there. First of all, the simple answer, Mr. Khan, is no. I mean, vehicle standards in Canada are a responsibility of the federal government and Transport Canada. And with respect, the City of London by itself should not and cannot be involved in vehicle standards. Leave it to Transport Canada. Obviously, you can advocate for things. The other thing, your preamble to the question referred to level 5. What I referred to earlier, and now that we're talking about levels, is a lot of the disruption will come from level 4 and level 4 plus. And we can argue about when level 5 will arrive, but it's very, very clear from GM, Ford, and many others that level 4 cars will be available in the early 2020s. As I said earlier, very in a constrained geographical environment, but they will be true driveless with no steering wheel and no pedals. So that's where a lot of the disruption will come, really starting in the early 2020s.
One question at a time.
No, I just want to elaborate my question.
Okay, elaborate.
So When I was saying that cities should come up, I was not saying that city have the power to overrule a rule already made by the superior bodies. I'm saying that, I mean, we are talking about road safety perspective. So every city has the Vision Zero. It started from Sweden, but now we have adopted to Road Zero. So my thinking was that, I mean, cities across the Canada, municipalities across the Canada, we have a setup with the government. So isn't this is the right time that all municipalities should talk on this topic and come up with the wish list and submit to the federal government?
I think that would be very good. I'm not exactly sure what kind of things you would come up with, but yes, and there already is. I know within Ontario, different municipalities are talking and working together. At a national level, the City of Calgary has also established a national working group with different municipalities. I know the City of Toronto is involved, and the City of Ottawa and others, really to share ideas, experiences and best practices, and that working group, both within Ontario and within Canada, would be a good focal point for the sort of thing that you're talking about, Mr. Khan.
Councillor Hopkins.
Thank you. And I guess my question will go to you, Mr. Olson, because you talked about the importance of getting cars off the road and how we mix and match our services. And I think there is consensus with the three of you that it is important to get those cars off the road as we move forward with our transit systems. And I guess the question again would be, how do we increase occupancy in these driverless cars, and where's the responsibility? I know the municipality could probably put bylaws in to say you need more than one person in a driverless vehicle, but I just want to understand the industry's responsibility and how important getting more occupancy in the car and getting the cars off the road is important for everything to move forward.
The people who are going to be operating mobility as a service also want to have people buddy up in cars during peak times. And so there's a natural incentive there between the city and the operator. And the reason is that you don't want to have a fleet large enough to accommodate your peak passenger load, because that means you have many more millions of dollars worth of vehicles that are only used during the peak times of the day. So I think the first thing I would say is that there's a natural alignment in the private and public interests to get people to buddy up. How to get people to buddy up, we don't know. I think this is a big question for the 21st century. I'm inclined to believe that the appropriate incentives, which could be, ride off peak and get a free ride, or surcharges. Whether it's carrot or stick, I don't know. But I do think that there need to be incentive mechanisms to encourage the behavior that we want.
It's not actually an easy question. I mean, we have a PhD student now working on the pricing of those new mobility solutions and how to price them right in such a way to maximize their benefits while minimizing the negative impacts such as zero occupancy. So it's a demand management problem, and it will involve a carrot and a stick, but it's not an easy problem. But fortunately, we don't really have ready solutions now.
Ms. Roof.
Thank you, through you, Madam Chair. Your comment of calling people auto captives, you've capsulated London in one word. And I would say from my experience that the competition for road share is not between transit and Uber and Lyft. It's the car driver and the different modes of transportation. And in London, there's a very strong stigma against transit. It's conditioned for just certain kinds of people with a certain income or socioeconomic status. So my question to you is, as we move forward, and obviously AV is going to be a big part of our future. How do we break that stigma down, especially if we move to a transit system that's AV, how do we still make that popular? How do we make it appealing to people who are the auto captives? And apart from a cost benefit, because if they can own a car, the cost factor isn't so big.
Yeah, so as I start, before even I talk about the AV, I mean, BRT was conceptualized essentially to try to really tackle this stigma problem. So even BRT systems really have certain characteristics that they have to come with, including the branding, the color scheme, the design, all of that really so that we can try to tackle this stigma issue. But adding to this, I mean, the point that I tried to make in my presentation, that we need to really envision the transportation system as an integrated mobility system. Public transit is one piece of it, but the Uber and Lyft and mobility as a service are services that can appeal to especially the young generation, the millennials, who tend to actually be attracted more to those services if we integrate those services in terms of the service design, the fee integration, the method of payment, of all those things, we integrate them well with public transit, then it's, that's, in my view, is really the ideal scenario, that we break down the stigma of public transit and we attract young people to use public transit through those services.
So, Mr. Khan, do you have another question? Go ahead.
Through the chair. So my last question is to Dr. Olson. I would like to hear from you that do you have any update from the Boston's Vision Zero approach where they said that AVs or the connected vehicles should be rolled out gradually, increasing geographic areas, and then if there is an experiment going on in certain areas, there should not be any human-driven cars or the vehicles in that area?
I think I'm more aggressive about it, about the deployment of AV technology than Boston. We take as a given that AVs need to be able to coexist with human drivers, and our vehicles are built with that in mind. I think if we artificially segregate those vehicles from roadways, you make the addressable market too small to attract the funding and talent necessary to go after that problem. And I think more to the point, it's the fact that we have to interact with human drivers and human pedestrians isn't on my top 3 list of worries. It's hard, but I think that is much easier than some of the other challenges.
For a change, Mr. Olson, I agree with you. And basically, I think that bus has already left the bus stop. You know, the whole trend is towards mixed use. My wish is that we keep that interim period as short as possible. But obviously be quite a few years, but there will be mixed use, and that's a given.
I'll go to Councillor Helmer now.
Thank you. I want to return to one of the implications that came up in a couple of your presentations, which is if there's large-scale adoption of AVs and there's a lot of shared use of autonomous vehicles, that the demands for parking spaces are going to change quite substantially. And so we have the blessing and the curse of being councillors making decisions that have long-term consequences. None of those are really as long-term as the physical infrastructure decisions and land use decisions that are being made, right? So how much area should be for parking, how much area should be for roads, what kind of infrastructure needs to be built underground and above ground. That's the kind of stuff we're wrestling with on this project. In terms of the parking situation, we have just over 1,600 hectares of surface parking in London. Imagine the entire downtown area as one giant parking lot, and then more than that is service parking. So private lots, you know, the spots where you can park on the service. We have parking minimums when people are building new buildings. We say you have to have this many parking spots for commercial, this many for medical office building, this many for residential buildings outside of downtown where the minimum is 0. What do you think we should be doing about the parking requirements and the parking expectations, considering the trend that we see with autonomous vehicles?
I think the important thing there, Councillor, is not that the City of London should be driving that trend, but to be prepared for it. That will happen organically as AVs become deployed in greater numbers, and you'll see the number of parking spaces needed decreasing, your revenues decreasing. One of the big questions for you is, as a city, is what do you do with the space? It was mentioned earlier about using it for development. In some places, there are people who would love to see some of those parking lots become green spaces. And if you've got parking lots downtown, and downtown is going to be quieter and less polluted, then more green spaces makes it, is a magnet and a sales point for people to live downtown. So I think my answer is really to be prepared and to start planning for what will happen, because with respect, I don't think you're going to be driving those changes, but please be prepared for them.
I just want to clarify before everyone else weighs in. What I'm interested in particular is, for example, we just had a large sort of single-story retail complex approved and is under development on Wonderland Road, which is a major road in the city. It's buildings at the back and a giant parking field, right? That is what is happening on the land now. And in the future, sure, somebody could build buildings out on the road and fill in the parking field. But right now, we're requiring all these developers to pave huge areas of the city, and we're still requiring them to do it over and over and over again, even though we're seeing this shift, which has happened rather rapidly. We haven't made any changes to parking minimums, for example. So that's why I'm asking, is because this is a private cost we're imposing on people. We're locking up the lands for quite some time, and I'm wondering about that. I know they can redevelop in the future.
I think you're between a rock and a hard place, unfortunately. I think the reality is that in the, what was the auto captive, that the term, that was a good one. What was it?
Yeah, auto captive.
Auto captive. You can't not have parking today. And the AVs are not ready to come in and take over, eliminate 80% of your parking. I think they can start to have an impact, but I think that transition is going to be slow. And at the same time, you have to have a plan for that land use when it does ultimately become available. So I think I don't envy you, in short, in terms of trying to figure out how to navigate that, especially given the time uncertainty of how fast will that parking requirement go down. Will it go down over the course of 30 to 40 years as maybe, the more bearish people would, or is it 10 to 15 years? If it's 10 to 15 years, don't build the parking structure at all. Just kind of hold your breath and hope for the best, and then reclaim the land for green space. But if you're more bearish, then you might not have a choice.
Dr. Chalabi, do you want to?
Thank you. A couple of quick data points. Let me preface this. I realize downtown London and downtown Toronto are two different universes. But in Toronto, they are building condos downtown with zero parking for the owners of the condos or the tenants. There's usually a few parking spaces for Virtue Car or whatever the local car rental place, car company is, but they're already moving away from that model. And there's a big incentive in downtown Toronto to not own a car. The flip side of that is a bit of trivia. I read recently in the US, for every single car in the US, there's a total of 8 parking spaces nationwide, which is just ridiculous. I think there is scope to cut back now, and there'll be even more cutbacks in the future. So it's not just a City of London problem. It's a much bigger issue as well.
I just wanted to comment on the downtown Toronto comment by my colleague here. The fact that you can do this because the public transit in downtown Toronto offers very high level of service, frequency of subway trains every 5 minutes, all day, from 5 a.m. until 1 a.m. You have supplemented by, high-quality streetcar routes. Now we have the King pilot, where we have banned traffic from along King Street. So you have very high-quality public transit service, and so you can afford to do that. Also supplemented this is supplemented by bike sharing program. So we have a very good bike sharing program in downtown Toronto as well for short trips. So in order to really achieve that, you need to invest in public transit, bring public transit in certain areas, downtown area, to a high level of service, and that will inevitably really affect people's behavior. They'll start walking more, biking more, taking transit, and the parking requirements will be definitely less.
Councillor Van Hulst.
Thank you very much. I'm a very willing auto captive myself. I'm also interested in money, and I'm guessing if I were to ask Mr. Olson, if cities were going to be able to compete with companies that offer mobility as a service, you would say, I hope not. So my question then is there something that a city can provide that can generate revenue? So in terms of the infrastructure, and I put this question through the chair to any of our panelists, if the city were to provide transponders in the road for location or 5G by the telephone poles, or dedicated lanes that here's a lane for AVs, maybe it's on the center or it's on the side, but you can use this for a fee, you can use our structure. Is that something that's conceivable?
Yes. If there's great infrastructure available and paying for the use of that infrastructure doesn't break the business model, and private companies can still find positive margins, they'll do it. I think the harder challenge, more broadly speaking, between the public and private is that private companies are playing a very straightforward economic game. How can we make money or create clear value? And every passenger that you create is contributing to the bottom line in a direct, accountable way. Public transportation has a very different problem in that oftentimes the bottom line, if you look at the cost, it's going to have to be subsidized, right? You're not going to be able to generate enough revenue organically from the transportation you're providing to cover the cost of the service. But you're doing it anyway because in the grand scheme of the economy of the city, it's worth having workers be able to get to their jobs. It's worth driving the economy by providing that transportation service. So it's one of these problems where the benefits are over here and the costs are over here. And so, I think that creates a very different mindset for how the public, the transportation planners are going to look at it versus a company which is going to look for costs and benefits in the same place.
Thank you. Talking about public versus private, Councillor Van Hulst, you're obviously thinking outside the box. I want to mention Innisfil, Ontario. I don't know whether any of you have looked into what's happened there in the last 3 or 4 years, but Innisfil, Ontario is a small town just north of Toronto, south of Barrie. And they, in fact, have, about 4 years ago, there was no bus service. The people in Innisfil wanted a bus service. And the town council looked at 2 options. One was to have a basic bus service on 2 fixed routes, buy the buses, hire some drivers, deploy bus stops and build a garage and all of those things. The other option was to contract with Uber. And they looked at that, and in fact, the theory was that the cost of a subsidized Uber service, and this is the objective, was to bring an Uber ride within Innisfil down to the price of a bus ticket. And they, in fact, went with a subsidized Uber service. Anywhere in the city, point to point, door to door, for the price of a bus ticket. And The people liked it. They did a review a year or two ago. The public in Innisfil like it because it's door to door. And also, council likes it because, as I said, the subsidy to Uber is less than the operating subsidy would have been for the bus service. My challenge to the City of London is, if you like most cities, on weekends, your buses are pretty well empty. In fact, to consider stopping bus service on weekends and having a subsidized Uber service. If the study is encouraging, to do a pilot. And you'd be the first major city in the country to do that. You get a lot of publicity, and it would be a very interesting experiment to see whether the outsourcing transit to Uber on weekends works.
Just one comment about the mobility as service companies. Now, Uber has applied, I think, for IPO, and there is going to be pressure really on those companies to raise their profit margin, because now they are actually not making money, but when they are going public, there will be demand by all stakeholders for them to make profit. So there is, I think, a concern now that also the price point is going to go up of those. So everything's still in flux. The Innisfil example is definitely, I think it's an interesting thought for weekend, but we need really to keep in mind that the Innisfil experiment, Innisfil is 1/10 the population of London, and sitting in the same area, land area of London. So really we're talking about a very small dispersed land use, and so which is very hard and very cost ineffective to serve by public transit. So, but the idea of doing it over weekend is an interesting one.
Councillor Lehman.
I guess that's a very interesting point. So when we hear solutions for Toronto, we're not Toronto. We're not in a small town, sorry, but we have to find a solution that's right for London. So that's why I'm cautious about comparisons to Toronto and no parking spots on their buildings. And, you know, they have subways, they have over 1 million people living within a small radius. So that's just a comment of where I'm at.
Anybody else that have any questions that hasn't spoken? No? Councillor Van Hulst.
Thank you very much. We've got $500 million that's burning a hole in our pocket, and we're going to have to make some investments in transit. And if we're looking seriously at a future that has autonomous vehicles, what kinds of things could we invest in? I mentioned the 5Gs or transponders in the roads, or what do you see would be a stepping stone for us to get to that new vision?
I'm going to be a bit scandalous, and my advice, Councillor, would be to hit the pause button on BRT and develop that vision to figure out where you're going. Clearly, with the way technology has evolved, the way I and my colleagues have been talking, there's a lot of options. It takes some time to figure out where the City of London should go. And you're right, City of London is not Toronto, it's not Innisfil. There may be lessons to be learned, but each city is different. So figure out that vision of where you want to be, not only with transit and transportation, but in the wider space by 2040 or 2050. That'll help to inform you. And one thing we've not mentioned, and very, very quickly, is non-passenger AVs. Things like the Netherlands has a prototype, as a pilot at the moment, for an automated garbage truck. It still requires a person. But, you know, if your garbage pickup is like mine in Ottawa, even in high-density areas, there's a guy who puts the garbage in the truck, then it's on the truck, drives a few meters, and then it's off. And in the Netherlands, it's an automated garbage truck that follows the human. So as the human walks down the street, the truck follows him or her, normally him. So there's other options, but really, bottom line, Councillor Van Holst, is I think it would be really prudent to not stop, but to hit the pause button and recalibrate what the vision really is and how to get there.
I think autonomous vehicles are another tool on the transportation planner's Batman belt. And I think the fact that we're here today indicates that you guys are thinking about what that tool can do, and when, whether it's a Phillips head screwdriver or a standard head screwdriver, you're trying to figure out when it will work and when it won't work. I think that's really good. In terms of your specific question, you've got money burning a hole in your pocket. I think I can't tell you exactly how to do it, but I think the goal should be to make sure you provide a transportation service that is good enough to radically change the equation of how people make their transit choices. I wouldn't spread it around so thin that you provide a 10% reduction in headway across your entire network, because that's not going to do it. But if you could do find some subset of the problems that you have and solve it with a capital S and an exclamation mark at the end, then that could be a model for the rest of your city and the rest of the universe in terms of what transportation is really going to work.
So in principle, like any transportation planning exercise, we have certain budget and we actually want to maximize the benefits. We want to see really what the biggest bang for the buck. Where can we actually, how can we use this money to achieve our mobility objectives for the whole city? So we need to be really surgical and target the spatial markets, the socioeconomic markets, where if we invest in those markets, then we can actually get the best benefit and the best bang for the buck. So many mid-sized cities, like I'm thinking in Europe, for example, have built very strong public transit network, really oriented towards the core. And this is where they could actually improve mobility around the city, but not everywhere, not across the city. So if you spread the $500 million across the whole city, that might not actually be the best approach. So in your case, I haven't actually reviewed the plan, but it seems that there was a decision to invest in those corridors, because this is the spatial markets where you can actually make impact. You may want to update and review the plan to look again at what really spatial markets and what socioeconomic markets that we can target, so that we can invest in those markets strategically.
Do you have more questions, Councillor? I have nobody else on my list.
Thank you again, and if you don't mind, a couple times I've touched on the dilemma of center lane and curb lane roads. So, and for our plan, we're going to have the plan we have now, center lanes with very large stations at 700 meters. Is that something, is that a step, is that going to be a step in the right direction or a step in the wrong direction is what I want to find out when we get to autonomous vehicles, whether they be, and I suspect they may be shuttles. A shuttle size is going to be a likely thing. Will we want those in the center? Will we want those on the sides? Can you give an estimate for me?
With the shuttles we have today, they're typically lower speed, so having them farther out from the center usually wouldn't pose a major risk to pedestrians. As I understand it, part of the incentive for putting a BRT or a light rail down the center is to keep the high-speed things, away from the curb edge. So I think that would still apply if there's a BRT or light rail there. For the shuttles, I don't think it would really matter whether we are driving down the middle or down the side. It's just that down the center might be a better place for higher speed vehicles.
In terms of spacing them of 700 meters apart, I mean, there is a tendency now in transit planning to increase the spacing between stations to improve the online speed, and now connected and autonomous vehicles or autonomous shuttles actually present an opportunity to serve short distance trips in between. So we need not really to go to the old fashioned design of having a stop every 300 meters or 400 meters, but we can space them out and leave the short distance trips for electric scooters or autonomous vehicles or other kinds of transportation, or even walking.
Thank you. In terms of your specific question, Councillor Van Holst, I don't have a comment there. That's not my expertise. I would say one thing to comment on your question is I think the future of mobility in the City of London is not just shuttles and BRT. I would also include in the mix automated cars, you know, four passenger cars as well. I think that's part of the mix. It's coming. That's easy to say. The real challenge, I think, is to figure out what the right mix is and the right role for each of those different kinds of vehicles.
Well, thank you very much. So the next question I have is just regarding the idea of arteries and capillaries. One place I see autonomous vehicles being really valuable is just picking people up in the subdivision and just taking them to the main streets. And is that pretty a likely way that's going to happen? And is that going to be a difficult thing, or will that be something we see soon, or sooner or later? And is that what we should think about for the future, through the chair?
There are two things that we really look at when we look at a potential deployment. One is the technological feasibility. Those sort of suburb feeders, last mile, first mile, are great fits for the technology today. They're not as great oftentimes from a market side, in that one of the challenges we have expensive assets, and we need to get a high utilization of those assets. So if we have a very diffuse fan out from a rail station to a square mile of subdivision, it might be very difficult to get enough utilization out of those vehicles to pay them, to make them worth the money. So we are typically today looking at low-speed routes in higher density areas as opposed to the first and last mile. We like to call it only mile. So the kinds of trips that you're already downtown and you're moving from one point of interest downtown to another point of interest downtown, those are great technical and market fits for where the technology is literally today. Of course, as time goes on, the technology will get cheaper and we'll be able to deal with a lower utilization of, well, the new technology will make it cheaper so we can handle lower ride demand areas and still make money, and we'll be able to operate at high speed. So the sort of zone of places that make sense will get bigger and bigger.
Okay, thank you very much. So thinking back to the 13 years and the two pictures with all the horses and all the cars, if in 13 years we're going to have a lot of automated cars that are connected, they may be connected with each other. And so I'm wondering what effect that will have. Certainly it seems like it might move things much quicker. It might be another quantum leap in safety if the cars all know what's happening, or they're connected to an AI that's watching the whole thing. So maybe I can ask our panelists to comment on that if they have a comment.
I do not think that V2V, vehicle-to-vehicle communication, is going to significantly accelerate the deployment of the technology. I don't think that it provides a significant safety benefit. That may seem counterintuitive, but when you look at the, because you think if every car is just telling everybody else where they are and where they're going, that would be great. The problem is that it's very difficult to make any guarantees about that communication channel. So what do you do if the communication channel is not working, or it's jammed, or if a malicious user is injecting false messages, or even if you just have a vehicle that hasn't been maintained correctly and is inadvertently publishing gibberish. Protecting against those factors makes depending on vehicle-to-vehicle communications for safety applications very, very difficult. And so we're forced down a path technologically where we need the vehicles to not be dependent on vehicle-to-vehicle communication. Maybe it can be used as sort of a hint, although I'm skeptical about that. Where I think communications like 5G and DSRC have an application is on optimization. So things that are not safety critical, but you're approaching a traffic light and you could phone ahead and say, hey, you know, it'd be peachy if that light was green in 15 seconds. And if it's not green, that's fine. You come to a stop anyway. So I'm not against communication. I think there are applications for it, but I don't see a great fit from a safety or it accelerating the technology itself.
I somewhat disagree, Mr. Olson. There is a lot of work going on. I mentioned with 5GAA, the World Group, and in the US as well, in terms of use of 5G for vehicle-to-vehicle. One important thing to bear in mind is one of the big differences between the present generation of 4G cell phones and 5G is this. All 4G and previous generation cell phones have to go through a tower, and there's a lot of latency. 5G has been designed specifically for device-to-device communications. So you'd in fact have a data link between two vehicles, and it will be very helpful in terms of collision avoidance. That's the main purpose. It will not prevent collisions completely. There'll be a lot of vehicles out there for the time being which don't have that technology. And for V2V to be effective, the vehicles have to be equipped. So it will help, and the car manufacturers are moving in that direction. But it's, again, as I've said before, I'm hopeful people don't overhype the technology because it won't solve everything.
Mr. Khan.
Through the chair, I think Engineer Kirk is more current on the technology. So what do you think about the common phenomena exists that for every 1,000 lines there exists a bug, 5 or 10 bugs? So in terms of cybersecurity, how we can ensure that this technology would be safe for the citizens?
Sorry, Councillor, sorry, Mr. Khan, I didn't quite understand for every 1,000...
Every 1,000 lines of code, there is a probability, there is a chance that we can develop 5 to 10 bugs. And initially those bugs are considered as features.
Thank you for the clarification, I misheard. That aspect concerns me less. One of the things we haven't talked about is cybersecurity. And that's a big issue, and it's a known issue. And basically, everything that is connected to the internet can be hacked. Every single thing. I was reading a few weeks ago about home automation systems and how hackers were able to unlock a front door remotely. I know that there's a lot of work going on near me. BlackBerry QNX is working on that. And they have a system at the edge of the vehicle to try and keep the bad guys out. There's another company near me called Odetto. And they have a different system in which they can detect when somebody has broken into the software and changed it, and changed the code, and they can then reload the original software. And this whole area of cybersecurity, it's very literally an arms race. The good guys try and prevent the bad guys, but the bad guys have a lot of clever people there, a lot of money, and they'll find a way around it. And it's just like a nuclear arms race, leapfrogging over each other. We will never completely solve it, and it's going to be an ongoing concern. We can try to minimize it, but that's one of the things I do worry about.
With regard to your question about bugs, functional safety, the sorts of functional safety analysis that we do assume that the software is buggy. So you can't go into it assuming that the software is right. Functional safety is about showing that a system is safe when it's broken, not when it's working correctly. And so the way that you achieve that is with layers of safety where you've got systems checking each other. And that's not to say that that this is an easy out, because of course the layers that are checking the other layers also have bugs in them. But it is possible to push the risk of a failure, an actual failure emerging from the system very low through very careful and expensive engineering. I'd also quickly address the comment here about cybersecurity, which is an important issue. One thing to keep in mind is that the vulnerability of a system is directly related to its surface area. How big of an attack target is it? If you are a website and you are designed to allow anybody to connect to that website and exchange information with it, you have an enormous surface area that bad guys can poke at. If you have a very, very small surface area, then there's much less area for a hacker to attack. So the reason I bring this up, our vehicles are not controllable via the internet, but they do have internet accessibility for exchanging information. But the surface area on these systems is tiny. The only service that we expose to the outside world is a single connection on a single port, which you require a cryptographic key and to be authenticated before you can connect to it. So only our systems can talk to our systems, and there is no public interface to the vehicle, and that reduces the surface area. Doesn't eliminate the risk completely, because if a hacker has the key, well, then they can get in. But we can reduce the surface area dramatically.
Councillor Van Holst.
Thank you. My next question is just about safety features, and through the chair, are there safety features available in autonomous vehicles and connected autonomous vehicles now, or you expect in the future that wouldn't be available to a driver?
The answer is yes. Let me mention one of them. A lot of the vehicle operating systems now and in the future use an operating system developed by BlackBerry QNX right here in Ontario. Let me preface my comments by saying self-driving cars will not use the Windows operating system. That's a joke. For obvious reasons. BlackBerry QNX got their start in life using an improved version of an operating system called Unix. And that was and is still being used. It's ultra reliable, and it's being used then and now, for example, for managing and operating nuclear power stations. It's that level of reliability. And what they're doing is to address also Mr. Khan's question as well. One of the things they do is that cars have 3 different versions of the same software running on 3 different processors made by different companies. And then there's a voting system. So the whole arrangement is designed to eliminate any systemic errors. And with a voting system, even if there is a bug in one processor or one of the pieces of software, the voting system, 2 out of 3, would eliminate that and not cause an incident. So BlackBerry QNX is really doing a wonderful job of applying their expertise in ultra-reliable operating systems from nuclear power stations for automotive use.
Perhaps the most obvious example of a safety system available on an AV that's not available on a traditional car is a vastly superior sensing system. So looking in every direction all the time, you know, the typical ADAS systems that are available on cars now are extremely myopic and limited. And so the cars have a fantastically upgraded field of view. When I was at Toyota, for example, we anticipated that a vehicle with a autonomous driving capability could also be used in a human-driven mode as like a ADAS, super ADAS, using that additional sensing capability to provide safety features, even though it's not autonomous.
Councillor Van Hulst?
Okay, thank you, and I am drawing to the end of my questions, and size matters here. There was an excellent graphic showing what it would take to move 50,000 people an hour, and so many cars and so many buses and one rail system. For London to move 50,000 people an hour during the day, we'd have to take everyone who lives in Ward 1 and Ward 2 and move them in the first hour to Ward 3 and 4, and then take those people and move them around. So we just don't need anything like that here in terms of travel, yet we're quite a bit bigger than Innisfil. So based on your knowledge of the size of the city, around 400,000 people. Can you give us a sense of where we're at in terms of that? What you might suggest we would need in terms of autonomous vehicles? Thanks.
Speaking to that graph, in general, we measure the person capacity of transit modes. I showed the extreme, which is the metro, 50,000 passengers per hour per direction. LRT and BRT, we're talking about, they could be anywhere between 15 and 20,000, and even 25,000 passengers per hour per direction. In some systems, they could even go higher than that. So the main question here is really for the corridor that such modes are being considered. What kind of passenger volumes are we talking about in terms of number of passengers per hour per direction? So if we're talking about, those, 25,000 passengers per hour per direction, then we need those, what we call medium performance modes, LRT and BRT. Metro would be too much for them, but regular buses wouldn't really be sufficient, because regular bus lines would provide you with a capacity of, 5,000, 6,000 max, per hour per direction. So I think the question here really is to provide the level of capacity, level of supply that would match the demand. The existing demand as well as the potential demand, because when you introduce those modes, they will serve the existing demand, but they also have the ability to attract additional demand by providing higher level of service, so you'll be able to attract more demand from other modes and also through developments along the route and so on. So it's essentially a supply and capacity, demand and capacity and demand and supply issue.
I think the one way to think about AVs and shuttles, the kind of technology that exists today, is that if your problem is throughput, the number of bodies you can move, they're not the answer. If your problem is latency and headway, then that's where they fit really well. So, we're looking at replacing routes where buses are overkill. They're too big. They've got 10 people on a bus that seats 50 people, and they're cycling only every 50 minutes because there's not demand for it. So I guess I'm kind of challenging the premise in a way that if you're thinking about how do I move 10,000 or 50,000 people at all, that's not where the strengths are. The strengths are where you've got underutilized buses, and what you'd like to do is to carry the actual ridership there, but with a much higher level of service quality, lower latency.
Anybody else? Councillor Van Hulst?
Okay, thank you. So we talked about the systems that the ride sharing where you get more than one person on a vehicle. And what are the odds that people are going to be saying by their phone, here's where I want to go, and then the vehicles are going to decide, for instance, you'll have a number of shuttles going by, and it'll tell you, get on shuttle 85, and you get on 85, and you wonder why the first two didn't pick you up, but it's because 85, everybody on 85 is going to the Budweiser Gardens or a similar location. Are we going to see a technology like that incentivizes people? I guess there's two ways to incentivize people, as back to Councillor Hopkins' question, how do you get more people on the same vehicle? One is you charge them less, which would make sense if I don't have to be charged as much if I'm sharing it with somebody. But the other incentive is if I get like an express route. So if it's actually handpicking who's going where, then I know that I'm not going to spend time dropping other people off, and I'll get to where I want to go. And how does that look like it will manifest in the future, Madam Chair?
One of the interesting things about our deployments now is that they tend to be full of, we call them busisms. So the transportation planners that we work with have a bus route. It goes around a fixed thing and it stops at these 8 locations. And that's actually a terribly inefficient way to use these smaller shuttles. Most of the time, a party, like a traveling party, will get on at bus stop 3, and then they'll have to wait for the shuttle to go to bus stop 4, 5, 6, 7, 8, where nothing happens at all, and then they get off on stop 8. So one of the things that is a real strength of the smaller vehicles is to take advantage of the fact that you have fewer pickup and drop-off locations, to allow a travel party to get on at one point of interest and then take them directly to their destination, short-circuiting all of the extraneous bus stops. In the long term, that's one of the reasons why shuttles are going to be able to, that they can so radically outperform a bus. It's not their magic, it's that because you've got one logical group all going to the same place, you can short-circuit the route and save a huge amount of time. So with your question, I would expect that we would absolutely see that. You might be standing at the brewery and see 5 or 6 shuttles go by before 85 comes and picks you up, because it's going to now be your space and take you directly to your destination. We also believe that experience is part of the unbus experience that will drive ridership and adoption. The bus stigma problem that we spoke about earlier. I think this is a way of creating that individualized, personalized transportation that makes it not feel like a bus and makes it is going to drive ridership.
If I can just may add to this that I mean, the methods are there really for what we call dynamic scheduling. You know, when you have a lot of requests for pickups and drop-offs, and you can pool people, and you can also schedule the vehicles in such a way that you minimize really the waiting time and also the drive time, the drop-off time within the window, the requested window. So the methods are there, and I think the technology, once we have those fleets of vehicles that they can be scheduled online, like in real time, to pick up, person 1, 5, and 6, and 7 all together in one vehicle, and then take them to the same destination or different destinations. So this dynamic scheduling methods are already in existence, and they can be put to use for such a use case.
Thank you. I want to add one other thing. Of course, you want to pool passengers so they're all going to the same place in order to make that work. The larger the vehicle is, the less likely you're going to be able to pool a lot of people. If you've got a bus that holds 50 people, you're just stuck. You have to go to every stop in order because you can't guarantee that anyone is going to the same place. And we also know from VIA and Bridge and some of those other intermediate capacity services that tried to pool and group people, that they actually weren't that efficient. They couldn't make money off of it. And so I think what we're learning from that from a transportation planning perspective is that the vehicles have to be quite small in order for you to be able to take advantage of that single party, single destination type of place. Our thinking is vehicles of capacity 6 or less or so.
Thank you. And just one postscript to that. Again, I agree with Mr. Olson, and it really speaks to the fact that one of the important components of any AV system with shuttles isn't just the vehicles, it's the back office system. There are companies nowadays that specialize in the back office system. So when you make use your smartphone to call a bus, it knows where you're going. It can do the aggregation of passengers based on origin and destination. I mean, I know one company in Europe called Best Mile that does that, and that's their main business. So when if and when you go into this area, don't just think about the buses themselves, but the kind of IT back office system needed to manage all of that.
Okay, I won't ask more than 3 questions. I guarantee one will be very, very short. Maybe it will be this one, Madam Chair. Mr. Olson, are your vehicles accessible, or do you plan them to be?
Our vehicles today are not ADA accessible. We have an engineering roadmap where we are making them accessible. That started with a wider door, which is complete and rolled out. But then ramps and securement devices are active engineering targets. So we expect to do that in 2019.
Just a postscript to that. A year or so ago, I went to 2 different workshops in Washington, D.C., hosted by a group called ITS America, who some of you would know. And the whole focus was, how can we make AVs more accessible? There's a lot of potential there, but after 2 full days of workshops, the devil's really in the details. And it's not really being properly addressed. And there's a mention about tie-downs. And one of the unfortunate facts is there are no industry standards for wheelchair tie-downs. And if you don't have universal accessibility like for Mr. Olson and his competitors, you do need some sort of industry standards, and there's unfortunately no real work on that at the moment. Another one, many of you will have seen the video a few years ago of the blind man in the Google bubble car. It's a wonderful vision, wonderful video, but if you try and encourage blind people to use autonomous vehicles, shuttles or taxis or whatever, the question is, if someone goes out of this building and is completely blind by themselves, and there's a bunch of different cars on the road, how do they even know which vehicle to get into? And in the course of 2 days, I've listed many, probably 100 different detail things. The devil's really in the details in terms of accessibility. A lot of work's needed, but it's important because there's a lot of potential there.
Thank you. This question involves the vehicle to infrastructure connections, and perhaps you can just excite us by telling us what's possible there if the cars can talk to the lights or other infrastructure. What advancements can we see because of that?
I can speak about public transit. So there's now TSP, Transit Signal Priority, where there is also some sort of communication between a transit vehicle and the traffic light, and then the traffic signal timing is modified in such a way to favor the public transit vehicle so that we minimize the signal delay. With V2I paradigm now, there's continuous communication between the bus and the traffic signal, as opposed to the current system now where you can only detect the bus at a single point in time, and then you make a decision, and then oftentimes that decision might not actually be the best. For example, extending the green for the bus based on the point of detection, which is a little bit far removed from really the time when the bus gets to the traffic light. So now with V2I, you have continuous communication, so you can always, you can continuously modify the signal timing such that you ensure that the bus would clear the intersection. So this is one of the applications in the realm of public transit that there is some great potential. Because currently TSP, as you probably know, is not necessarily, it's a very cost-effective strategy, but if not really done right, there's a lot of so-called TSP failures where you grant a green extension, but it's not made use of by the bus. So with V2I, you reduce those instances of extension failures.
So, Councillor, I'm not sure if you're done with your questions, but I do know a number of members of the working group have indicated that they have other commitments, including Councillor Pelosi and myself are supposed to be at the Board of Health right now. I'm wondering if we might be able to wrap this up. We've been at this for almost 3 hours.
I'm happy to let you wrap that up, and my great thanks to the panelists for all that they've been able to offer us in terms of a vision of the future. Absolutely. So thank you.
Thank you all for coming. Mr. Kirk, Mr. Olson, Dr. Shalabi. Sometimes differing views, always good to hear such a wide breadth of information, and it's certainly a lot of information we can use to make decisions as we go forward. So thank you very much for coming and sharing with us. So what we need to do is receive those presentations and receive the information that was shared with us through the Q&A. Moved by Councillor Van Holst and seconded by Councillor Helmer. All in favor? Any opposed? I see none. The motion carries. Thank you again. Next, we have the consent items, and it's the fifth report of the Rapid Transit Implementation Group, as well as the Municipal Council resolution adopted at the December 5th meeting. We can move those both together, I believe. They're both receipt. Moved by Ms. Park and seconded by Councillor Keabaga. All in favor? Any opposed? I see none. That motion carries. I see no items for discussion. I believe there are no deferred matters or additional business. I will look for a move to adjourn. Moved by Councillor Keabaga, seconded by Ms. Ruth. All in favor? None opposed. Thank you.